That there. Okay. I posted, and this could be, okay, fortunately it's there. Is my Wi-Fi connected? Let's see if the Wi-Fi even, I find that the Wi-Fi here is sometimes challenging at best. Do you guys have much luck with the Wi-Fi on this campus? No? Not there? It works some of the time, then other times it doesn't. Right there. Well, it does want to identify my username and password. Yeah. Let me plug this in and forget the Wi-Fi connection that's there. And hopefully we have everything we right there. Okay. I posted the link to this website on the Facebook this morning. That there, as I was sitting in my office losing track of time, figured I would do it before class instead of after class. That way, but there. This is actually the configuration of the keypad that we're going to be using. I was going to bring the little box down with the keypad. I have a keypad in. Our keypad is very small, and if we were to look at it, right there, it looks like this right here, and it's got 1, 2, 3, 4, 1, 2, 3, 4 little pins on the bottom, which these will equate to those same pins that they're. As I recall, these are the columns, these are the rows. I can't remember for sure. And then we've got our 16 buttons like this right here. And when I say it's very small right there. And I mounted on the keypad a little connector that you can go connect between that and the 8051 board right there. So we'll use port 1 on the 8051 board to do this lab right there. So as we go through the lab, keep in mind that we'll be using port 1 and not necessarily what's in this code that's given at there. So with that said, look at this right here. You can see here, these are our 4 connectors right there across the bottom right here. And these are our 4 rows. Now those are those 8 connectors on the bottom of the keypad. And the keypad is only like maybe, I want to say maybe 3 centimeter by 3 centimeter. It's very small, that there. So you'll have to wire this up to the 8051 board right there. And as you recall, the 8051 board has got that little header on the bottom of that there. So you have to look back at the data sheet for the 8051 board. Right there, and hopefully it's, I have a directory called desktop stuff that my desktop got so full, so I stuffed everything into a desktop right there. And I'm going to find the data sheet here for full stick here. Is this the one? No, this is not the one. This is the... Yeah, I guess it is the one. Okay. All right, if we look at this document right here, and if this is not on Facebook, I will put it on Facebook tomorrow morning, or because in the lab I've got access to the internet. So let me just gonna rotate this. More rotate. Right there, and we got to rotate it a couple more times. Right there. So as we look at, this is our chip right here. This is our chip right here. Now as you look at it right here, we can see port 1 starts, let's see, where's port 1.0? Port 1.7.6.1. Yeah, right here. Right here is port 1.0. And we go around. This is not connected right there. So pin 13 you ignore right there. Right there. So ignore pin 14 or 13. And you come around here, and then port 1 comes up there. So you have to connect to the board, to the keypad, according to the pinouts that we'll talk about here right there. So, but this is our chip that's on the 8051 board, and we have to connect to port 1. Now, the LED may come on and off that there, as I recall, that there, we've got port 1.7 as a push button, don't push that, and port 1, where's our LEDs right here? This one here may, these LEDs may come on and off as we go through and do the lab out there. So that there, just ignore those LEDs if they do come on. Right there. So that there. Okay, getting back to this right here. So this is the status each key here. We've got 4 columns and 4 rows, and what we basically do is we take and we put a logic low, and let me see if I can. Oh, let's do a Control A. Copy. I'm going to see. Actually, what we could do right here is we could do a print. Save as PDF right there. 16 pages. Save. Save, and we'll just put it on the desktop. Yep, there we go. The reason I'm putting it on the desktop is so that I can write to it. Right there. Okay. So as we look at this right here, and we'll figure out here as we go whether this is going to be tied to port 1.0 or this is going to be tied to port 1.0. Either it doesn't matter which one we tie it to, but our software has to match how we wire this up. So as we go through this right here, this is the wiring that they use. Unfortunately, they use port 1, so we don't have to change their software. So we could basically just use this this wiring diagram as it is right there. Keep in mind that these are our rows right here. So our rows right there, when we look at the little keypad itself, and I will probably have to spend like 2 minutes figuring out which ones are the rows, which ones are the column. All it takes is an ohm meter, and you hook it up on 2 of the pins, and you push a button, and then you go through. And matter of fact, that may be part of the lab, is for you to figure out the wiring diagram that there. We'll talk about how this works here in a second. But what we do in order to make this work right there is we tie this row low and we tie these 3 high. And then we look at these 3 and we look for a low. Now we write a 1-1 to the other ports. We just tie the 1 line low, and we tie so we write out to port 1. Basically, if we're going to tie the first row, we're going to write FE out to that port there, and then we write, then we go down and we take 1 row at a time. So we're going to write, going back to our software, right here, and this is our basic software right here, and ignore this part here, right there, because that's for an LCD connector. That's the next lab. We're not going to worry about it. So don't worry about that part of the software right there. This is the keypad connections right here. So this defines all of our various rows and our columns right there. So again, that's going back, assuming we wire it up according to, that they're in. Again, I gave you the pinouts for the 8051. That document will be posted on Facebook at the start of the lab tomorrow if I don't remember to post it when I get back to the cubicle right there. So that there. We have a little delay, which we'll go ahead and put that in. I don't think we use that for this week, because next week we'll just add to this lab right there. All right, this reads the keypad right there. And notice, welcome, that what we're going to do is we're going to start off here, and we're going to set everything high except row 0. Row 0, or row 1, excuse me. No, again, it's port 1.0, that there. We're going to tie that particular row low, right there. And then we do a C1 is equal to, if C1 is equal to 0, that means that somebody has pressed that button. Going back and looking at our keypad, right there. This is port 1.4 right there. So this is kind of a reverse order. Now the exact value you're going to do, it depends on the keypad. You may have to change this according to your keypad right there. Our keypad doesn't have this exact configuration right there. But regardless, this is saying that if I press that button, this row is low, this one's high, 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 and if this button pressed is a low, that means that this is going to be a low. We don't care what these 3 here mean, right there. So that's there. So with that being said right here, what we're looking at right here is we're looking for if C1 is equal to 0, and C1 is the return line, that there, our first column, if that's equal to 0, we do a delay. The reason for the delay is whenever we press a button, we have what's called debounce. And debounce is that we press a button, it opens and closes several times, and we get multiple switch closures. So we just do a short little delay after the time we press the button to make sure that, to let things settle up. And then it says, and then while C1 is equal to 0, we just sit there and we wait, right there. And then we return back a 7. So this is the function that reads the keypad, right there. So all we're doing is if that button is closed, we have a delay, and then we sit and we wait for that button to, while the button's closed, we don't return. In other words, the program just locks while that button is closed, right there. And then we return a 7. Now, some people will put in here another delay, right there, for the opening debounce, right there. Because when you close it, there's a debounce, and when you take your finger off, there's a debounce. You know, I usually put in an extra delay after that there. So I put in a delay first, and then a delay afterwards, right there. But this is actually 3 instructions, so, you know, the way you learn C, you would actually write that on 3 lines, right there. You would say, if C1 equals 0, bracket, and then delay 100, right there, while C1 equals 0, that's our stall, and then our return 7 right there, and then our close our bracket right there. So it's basically you got 3 instructions: 1, 2, 3, 4 if you put the second delay in, right there. So, and you repeat that for column 2, 3, and 4. We just simply repeat that. So all we're doing is we're looking at each column one at a time and see whether it's a 0. Now, there is a problem here. It's not much of a problem. The problem is if I hit 2 keys at the same time, it's only going to see the first key right there. So this doesn't have what we call 2-key lockout. In other words, it only looks at, if I could do it exactly the same time, if I hit the 7 and 8 exactly the same time, it only sees the 7, it won't see the 8. But if I hold the 7 down and I press 16 keys, it won't see any of those 16 keys. It only sees that first key that's pressed right there. So, and then we turn right around and we change this to row 2 right there. So, and then we do the same thing. If the first column is equal to 0, we return a 4. If it's equal to, if the second column is equal to a 0, then we return 5, and we go on through. We return each of those right there. We repeat again for the 3rd row right there. And then we repeat again for the 4th row. Now, I'll tell you right now that on the final exam last semester, I put the circuit for the keypad up there, in other words, and I asked the students on the final exam to write this function. This function is not difficult if you understand how it works. I don't encourage you to memorize it for the final exam. I encourage you to understand how it works right there. But it's a very simple function right there. So all you're going to do tomorrow is you're going to implement this function. Now, your lab is going to be a little bit different because as we go through your lab, you're not going to bother with the LCD for right now. We're not going to worry about the LCD. So we're not going to do any of this right here. Right there. We're not going to do any of that right there. We're going to skip that for right now. Hopefully we can get that working in another week or 2 after that. We'll go through, talk about the LCD. While P is equal to C, basically, again, we just simply skip that part. Right there. And all we're going to do is you see, and again, what we're doing here is this is keeping track of how many times. We don't need the I there. Right there. All we're going to do is P is equal to C. We don't even change P anywhere here. Char P is equal to that there, while 1, P is equal to C. C is, okay. This is incrementing the keypad, which is fine. We could leave this code in here. Right there, or we can just simply delete everything here, right there, all the way up to here. Actually, leave that one there. You know what? Let's not change this too much. Let's Let's leave the format alone, because if we, for tomorrow's lab, delete anything that starts with LCD. Delete that, delete this, right there. You can leave this here, because we can use that for a debugging tool. You can leave this here. Now, keep in mind that I said that I would normally stick that second delay in there. There's no need in this case, because this particular code sticks the delay before the call. So that's the equivalent of sticking the delay before the return. So there's always a delay after the key has been pressed before we start scanning the keypad again, right there. So all this does right here is that here it says while not C equals, so this is going to return back a key press. C is the key press that's been pressed. So when we go through it and we debug our code, we will set C as a watch value so we can see what it is. That there, and we'll put a breakpoint right after here. We'll set the breakpoint right here. Is where we'll set our breakpoint. We can actually set our breakpoint various other places. During the lab, we'll talk about that. You know, we're basically going to run this. We're not going to get any output from the program. Our only output is going to be in our debugging window. That when we press a key, we'll see it. We'll see it stop. You know, the code will stop as soon as we take our finger off the key. It'll stop, or we put our breakpoints, you know, throughout our code just to watch through what's going on. A single step through the code, put a breakpoint, and watch through, and we can see what's happening on the various lines. And then once we exit this line here, right there, and the next line that's being exited right here, after that's going to be exited, is actually going to be right here. That's going to be our next line right there. That's it. So, or it's going to be right here. Because we're going to drop out, because as soon as we take our finger off the key, it's going to drop out of this loop right here. Right here. This loop, it's going to drop out of that loop right there. And it's going to go back to this while one. But we deleted all this. So this would be the first line executed once we take our finger off the key. So we'll put our breakpoint there, and we'll see what C is equal to at that point to see whether it's working. But I actually encourage it, instead of just see whether it's working, we actually step through it, and I'll do that as part of the demo as we do the lab. We'll step through it, that way we can see how it's scanning each one of those keys right there. And then we can see where it does the return if a key is pressed. So, but the lab is basically to implement this code and test it and make sure it works and verify it line by line and to verify the pinouts on the keypad. So to verify the pinouts on the keypad, that's fairly straightforward right there. Our keypad looks like this right here. It's got 8 right here. And I've already given you a hint that there's a group of 4 for the rows and a group of 4 for the columns. I don't know what order they're in. I used them last semester. I've slept since last semester. I've taken vacation since last semester. I've taught a lot of classes. I don't remember what they were last year. I didn't write them down at there. They didn't come with a data sheet. I bought them cheap from a company in China that sent me a bag of them for like $3 or $4 US. They were like 50 cents a piece or so. I mean, they're extremely cheap keypads because, you know, I didn't have any in the lab to speak of that I could get my hands on, so I just bought whatever was cheap. That there. And that there. So I know that these 4 are either the column or the rows. Right there. I don't know what 4 they are. And they may be 1, 2, 3, 4, or they may be 4, 2, 3, or 4, 3, 2, 1. Right there. Same thing there. So what you do is you grab, say, 1, 2, right there. Right there. And you know, basically what, and you can actually start off at the top right here. And you can push that button right there. And you take an ohm meter and you put the ohm meter between here and here. Does it show a short? No. Does it show a short between here and here? Does it show a short between here and here? And you look to see which ones are identified. So you've identified whether the first row or the first column is on this side or is on this side or that side. And you also identify whether the columns, whether they're ordered 1 through 4 or 4 through 1, right there. So you do that. And then you go through and you move your, push this button and you repeat that. And what you'll find is that one of these is going to be, say, if this is the first one and this is the first one, so they're ordered 1 through 4 in this direction, then this one there might be a short between these two or a short between these two right here, between these two or these two here. And that's going to tell you which ones is the columns or the rows. And you just go through it and just double check that if I close, say, this one here, I'm going to get a short here to here, right there. So you're looking for the shorts as you push the button, right there. Because you got to remember, each one of these buttons, what it does is it shorts between a column X and a row X right there. That creates a short. So all you got to do is push the button and look for the shorts. And you can come out with the pinouts fairly easily that way. So that would be your first task, is to figure out the pinouts of this keypad. Once you know the pinouts of this keypad, then you also need to go back to this code right here. And this code here, right here, you have to change all these to match what keypad you have. Right there. Let's say your keypad is of the format, and I don't know if it's of that format. I'm just making numbers up here at this point here. But it may be something like a normal keypad. Right there. I'm just going to pull up my okay. Let me give me a second here. I gotta find my. There's my phone. All right. It may be 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, star, pound, A, B, C, D, something like that. Right there. I don't know what these keypads look like. They're not in front of me right there. So I mean, I could probably pull up and try to figure out which one I ordered from Banggood. That's who I bought them from. But what you need to do is you need to look at the keypad and note that this is row 1, this is row 4, this is column 1, this is column 4 right there. And actually that's different than what they did. If I recall, they did this row 0, okay. Okay, they did this row 4 through 1, I think is the way they did that. But again, you have to match the keypad with these return lines right there. So in other words, you have to look at their keypad, and it's got this configuration. Our keypad may have a different configuration. So wherever their keypad they put the division symbol, you have to replace it with what's physically on our keypad, so that our numbers match the keys that we press. If our keypad has got a different layout, which I know it does, There, and I got one sitting on my desk upstairs. I meant to bring it down with me, but I completely forgot it on my way down here when I realized I was running late. But this keypad has to match that there. So that's the second part of the lab. So as we go through the lab, part one is to figure out the wiring of the keypad itself. That's part one. And to do that, you'll have to check out an ohm meter from Yati. Actually, you'll have to check out the board and the keypad from Yati as well. We've kind of gone to a system that we're making everyone check things out. And then two of my boards came up missing in the microcontroller class right there. So actually, it was this class. The last time we had a lab, two of the boards walked away. I don't know whether it was this class or where, but two boards are missing, Yati says. So she's now making sure that she knows who has what board out there. So if you do have one of the boards from last time, you threw it in your bag, please return it, okay? Because I'll be honest, I buy those out of, the replacements I end up buying out of my own pocket because it's not worth the paperwork to submit the receipts. They're 40 ringgits. I spent an hour and a half filling out the forms and justifying buying them things. And then 2 months later, I haven't got my money back, so I check into it and I have to resubmit it again. So after a while, I give up and just simply kiss the 40 ringgits goodbye. So as a result, if you steal a board, you're stealing the 40 ringgits from me, not UniKL. It's coming out of my pocket because I'm the one who ends up buying the replacements. Because the paperwork to do that through here, it takes months to. If I waited for UniKL to buy the boards, and I'm not picking on UniKL system, but it's like every other system I've dealt with since I've lived in Malaysia, is that by the time it goes through all the approval processes, it's 2 or 3 months down the road, and that's when the replacement board shows up. and we can't wait that long. I get online and I put in my credit card or debit card number, I get the board the next day. And then I submit the receipt, and then it's 2 or 3 months before I get get my money back. So so I end up never getting my money back in most cases. If I pursue it, it's not that they don't pay me, it's that I'm the one who gets lazy and gives up. Because let's see, I went to a conference in October, and I think the registration fee was just paid last week. That kind of gives you an idea how slow the reimbursement process can get. So as a result, you'll have to check out a keypad and a board from Yati and you'll need to check out an ohm meter as well. And then she'll probably just give you she'll just probably put a box full of wires in front that we use for connecting the keypad. So step one, figure out the wiring for the keypad. Step two, modify this code right here, and it's all in this function here called read keypad right there. And incidentally, another reason why I suggest that you don't memorize this code is if I do put this question on the final exam, I reserve the right to put any random keypad on there. The keypad may not match what's in this website, and may not match what is in the lab. I may put a random keypad that has the letters A through F on it, right there. You're not A through F, but A through whatever the 15th letter of the alphabet is. So instead of starting at 0, I might start with A and just have random letters there. Or I may put X, Y, Z, A, B, C, D, E, F. Something like something completely random on the question. So But part two again is to modify this where this 7 actually matches. And this 7 in this particular case matches what they're calling row 1, column 1. See, he starts everything on the top and the right. I'm thinking our keypads start on the top or the bottom and the left. I think they're the exact opposite right there. So, but regardless, when you look at the way that he's numbered our columns and our rows right here, this is the first key press right there. And since we're doing the row, the next one is this one, and this one. So you would look at the keypad, if it's wired exactly the same as what he's wiring this, and again, I would probably just wire it the same way. So, if our board is such that this is, say, row 0, or row 1, excuse me, row 1, or he called this A right there, that would go back to this wire would go to that one right there. So that would actually go to the, because this just shows A, B, C, D, and 1, 2, 3, 4. That's perfectly fine, but what he's not showing is the connections right there. So what you have to find is you know, we've got A, B, C, D, and what did he call this? 1, 2, 3, 4, he called it, is what he called it. So you have to find out which connector here is. So if this is row, this may be A, and this may be 1. This might be B, C, D, 2, 3, 4, right there. So you have to figure out that wire, that there. So then you would wire that to the correct port on P1. So that's step 1. Step 2 is you look at this keypad and your keypad, and if you follow that same wiring, all you have to do is start here and go across this way, and then come here across this way, and across this way, and replace in this code. That's the 7. You know, most of the subroutines on that page there, right there, and just simply replace those with this is the first row, the right to left. This is the second row, right to left. And you just look at the keypad and you replace that there. Then the third part, of course, is once you've done that, you compile the code. Again, delete all the LCD references. You know, just delete them. You know, don't bother. You can probably copy and paste this code actually from the website. There, it's all one continuous form cut, and just delete those lines you don't need, or just comment them out knowing you're going to need them later. Right there. So later on we'll talk about the LCD. So you can just comment them out. Just put a semicolon or put a dash in front of each line, or put a asterisk star. I mean, this is put that there to just comment out those lines. Or I believe you can put a dash or dash like that. I can't remember the comments for this particular compiler. Most of them is dash / right here, right there. Yeah, see. Yeah, if you just put this at the beginning of the line, that comments that line out. So if you just do that every place where I put a big XX right there, or you can just put a star here and then one down here, right there, and that just comments those lines out right there. And you'll see that they're commented out when they turn green on the compiler right there. They'll turn green or blue or some other color that there. So, and then, you know, again, you do the same thing with these lines here. You just comment those out right there. Comment that line out there, right there. So, and then the last part of the lab is once you compile it and download it, is you're going to go through, and what I would suggest you do is the first time put a breakpoint here, you know, the little stop. In other words, put a breakpoint here and single step, and then put, as you single step through that there, just look at port 1. You know, in other words, bring up the watch window and look at port 1, and I'll show how that's done tomorrow when I've got the board in front of me, right there. How you would put the breakpoint in and stop it, and look at what port 1 is as we go through each one of these lines. Press a button and go through and see what's happening, and make sure you understand how this function works. And then the last thing you would do is take that breakpoint out and put in the breakpoint, as I mentioned, right here, and just press a button and see what C is equal each time, right there. So I press a button, and C is going to be equal to something when it returns back, right there, because right here, C is equal to whatever the keypad returns. And the one thing I didn't comment on is if no key is pressed, this is going to return 0. Now, keep in mind that if I press the 0 button, this returns the ASCII value of the 0. So 0 here does not equal 0 right there. So if no key is pressed, that returns the number 0. If the 0 key is pressed, it returns the ASCII code for 0 right there. So they're not the same. I'm thinking the ASCII code for 0 might be 48 or something right there. So, but when you tell it C is defined, by the way, as a char, so it will show up as a char if you take the default type in the watch window. So it'll show that whatever character you pressed right there. And can't remember. Oh, returns an X plus minus, what's it return for? Oh, divide, it returns the slash mark right there in this particular case right there. So that is the lab. So your lab report would be a formal lab report. I'm going to grade this lab, so you can do it one lab per group, but keep in mind everybody in the group gets the same grade right there. So if you're going to do a group of 3, all 3 of you are going to receive 10 points or 3 points or 5 points, whatever the group gets. So be sure that whoever's writing your lab report that you help them out with things such as grammar and make sure that the lab report is up there. I don't want to see 15 lab reports that look identical. I've had that happen before. In other words, one group writes a really good lab report and they share it with all the other groups. I would expect that each lab report looks unique. I'm going to be grading the lab reports on a scale of 1 to 10 at there. In most cases, most people are going to get an 8 to 10 on the lab report if you did the lab. In other words, if you lose a point for something, it's going to be something minor. I don't fail people on labs that they do and actually that they're. I might ding you on a point if you forget to give me a copy of the code or you don't show me screenshots of going through some of the watch points at there. So you want to capture screenshots, showing that I pressed the 7 key and this shows that the 7 key was pressed right there. And you don't have to do that for all 16 keys. Do it for like 3 keys, at there. If you do it for all 16 keys, I'm going to get 10 lab reports that are going to be 20 pages long, and I don't want 20 pages of lab reports. I want somewhere around 2 to 3 pages tops. And that includes a copy of your code, which takes up almost a page right there. And then if you put in 3 or 4 screenshots, you've got another page here. So you're only talking about a paragraph out there, a short little procedure of how you found the pinouts, what your pinouts were when you were done, a copy of the code that you modified along with actually the ideal case is either a drawing or a picture of the keyboard itself to show that you modified the code to match the actual physical keypad, and then a short little explanation of how the code works, along with a couple of screenshots showing that you executed the code there, and a little short conclusion. I learned this in this lab. I learned how to follow directions, but I still don't know how a keypad works. That there, but I'm being sarcastic with that. Sarcasm means I don't want you to actually write that down. I have no clue what I did, but the instructor said it worked. Don't write that down. Hopefully you understand how it works. Right there. So that's the lab for tomorrow, right there. So we'll probably be picking weeks that we do have labs. I'll probably use the lecture time to explain the lab and then let you do the lab. Weeks that we don't have lab, we probably just won't meet during the lab time there. So I hope to have labs most weeks. That's there. So and I talked probably my good 45 minutes. That's short. That there, I could actually go and cover some theory, but I didn't develop a lecture on theory. So let's just kind of just keep it to the lab discussion today. That there. So it's relatively short. And then tomorrow, just come in and do the lab. This lab will probably take an hour or better by the time you go through all the parts, is what I've discovered. Previous 2 semesters I've gone through this lab. It's taken the better part of the hour because even though you cut and copy the page, I could actually do this in probably about 10 minutes, but I'm finding most people take about an hour by the time you find a little bit of problems with their code. Remember, because the only code you did so far is Blinky, right? At there, and then you did a couple labs last semester. So most of you probably still are fuzzy on the procedure still. So So figure on at least an hour to an hour and a half, if not more. Funny thing is, I've actually found that most time here in the lab sections, most people are there the full 2 hours. So, all right, I will see half of you tomorrow morning at 8 o'clock, is that right? And the other half Monday afternoon at 3 o'clock. 8:30. I mean, we can start at 8:30. Yeah, it shouldn't take more. Actually, if it takes you more than an hour and a half, then you're just wasting some time. This lab should be done by an average student in about 45 minutes to an hour, but I find here that it takes closer to about an hour and 15 minutes, hour and 20 minutes, to an hour and a half. If it goes beyond an hour and a half, then you can come back on Monday and finish up with the Monday group, but it should take you over an hour and a half. So 8:30 tomorrow, and then 3 o'clock on the Monday group, right? Okay.